Okay, so now let's pick up with calculate the resultant and the angle and then the moment due to that. Alright, so same way we've been finding things over and over. R is going to be made up of X and a Y component. So Rx, let's see, F1 is all X components, so it's 25 pounds and it's in a positive direction. Alright, then F2 does not have an X component, so we can ignore it. And then the next one we need to add is the X component of F3. The X component of F3 is negative, so it will be minus 75 pounds times the sine, oops, that's cosine of 15 degrees. Okay, so Rx is equal to, punch that into my calculator, I get negative 47.4 pounds. Ry is going to be equal to, well, there's no y component of F1, so we can ignore it. F2 is a straight 50 pounds in the y direction. Okay, and then F3 is also in a positive y direction. It's going up. Okay, and so it is 75 times sine 15 degrees, and Ry is equal to 69.4 pounds. Okay, now we know that R is equal to the square root of Rx squared plus Ry squared. So R is going to be equal to the square root of 47.4 pounds squared plus 69.4 squared. So R is equal to I get 84.0 pounds. Remember that when I square 47.4, it becomes a positive number. All right. Now the angle comes from tangent, we'll call that angle A, is equal to Ry divided by Rx, which means that A is equal to the arctan of Ry is 69.4 divided by 47.4, and I'll plug that into my calculator and get 55.7 degrees. Okay, so now I have my angle, I have my magnitude of my resultant and my angle. It's going to be somewhere over here. Okay, and I need to break that down into what is the moment going to be. Well, if I look at the components of this one, all right, if I just think about my Ry and Rx for a minute. Okay, Rx is again in the line. It's not going to contribute to a moment. It may cause a translation, but it wouldn't cause a moment, a rotation. Ry, however, will. Okay, so the moment about point O for this one is going to be solely due to Ry. Luckily, I already have Ry calculated right there. So our moment is going to be, and now we're on part D. Okay, the moment at O is going to be equal to the 69.4 pounds. Oh, the distance is still the same. It's still 6 feet. Okay. So the moment at O, point O, is equal to 416.4 pound feet. Oops, what happened? Got a little click happy, must have brushed it with my arm or something. Okay, and so when I look at that, that is a positive moment. It's going to tend to cause a counterclockwise rotation. And that is essentially the exact same answer as I got for part B. See, 416.5 and 416.4. That's a great thing. The point of this is that whether you compute the moment for all the individual forces or whether you compute it for the resultant, it is the same. It appears to be the same net effect on the system. That's always true. Hope this helps.